So my pleasure to make a presentation on desertification. I will start with the very definition of the word desertification. This was employed way back in 1949 by a French forester, Agronomic. He primarily used the word desertification to mean that it's the replacement of the tropical rainforest by secondary savanna and scrub in those parts of Africa where forest was being cleared and burned also to provide for land for cultivation. So he did indeed say that true deserts are being born in front of us at present time in regions where rainfall ranges from 700 to more than 1500 millimeters. And of course, several years passed after this definition by Agronomic, and then UNEP in 1990 attributed all the desertification to human activity. Land degradation in the arid, semi-arid and dry subhumid areas is what they define as desertification, and they have attributed it to adverse human impact. And then in 1995, the United Nations Convention to Combat Desertification, it also allowed a little bit for other factors, not just human intervention, but also climatic variations and as well. So that made us in WMO pretty happy that at least climate is now recognized as well as a contributing factor to desertification, not just human activities. Now what's the problem of desertification globally? The Earth as a whole, we have 145 million square kilometers of land area. Of that, drylands occupied 6.31 billion hectares, or approximately 47% of the total land area in the world. Of this, drylands, major part is in Africa and Asia. As you see, both Africa and Asia cover about 2 billion hectares. Australasia about 0.68 billion hectares, North America 0.76, South America 0.56, and finally Europe 0.30. And there are a number of different ways of estimating desertification. This is one estimate from GLASOD, the Global Assessment of Desertification. This is from an organization in the Netherlands. As you could see here, there are a number of factors that contribute to desertification: water erosion, erosion due to wind, degradation due to chemical factors, due to physical factors. And you notice that the maximum amount of desertification takes place because of wind erosion. And that's the reason why in many parts of North Africa and also in other parts that you have this problem of desertification because of the wind erosion problem. This is followed by erosion by water, and then of course you have impacts due to chemical as well as physical degradation. One of the major factors in most of the drylands that contributes to desertification is overgrazing. This is, in the rangelands, it is identified as a major cause of desertification because when there is overgrazing and whatever little cover that is present on the land is removed by the animals that are grazing, you lose the grass cover, you lose the shrub cover, and then that of course accelerates the erosion. Then you also have a combination of not only overstocking but also poor land management. In many places, many of the herders really don't have the technologies for them to manage these open land areas effectively. And of course, whenever you have periodic droughts, as it happened in the Sahel in the early 70s, late 60s and early 70s, you do have a tremendous amount of degradation due to a combination of factors that is aggravated by droughts. What happens then is you have, I'm not very sure how this operates. You have on the right side, on the left side, the situation of overgrazing, and when you have Thank you very much. When you have overgrazing, you have reduced vegetation which leads to higher albedo. Albedo is the percentage of radiation that is reflected back. When you reduce the vegetation, a lot of that radiation is reflected back, which then means that you have lower net radiation, that is the net amount of radiation that is available for energy processes. When you have low net radiation, you have cooler atmosphere, and that leads to less rain, and hence you have reduced vegetation. This is kind of a vicious cycle that leads to desertification. On the right side, you see that when we have reduced grazing due to managed pastures, as it is, for example, in Australia, when you manage the pastures properly, you can increase the vegetation, and then, of course, that leads to lower albedo, and then greater convection, more rain, and so on. So this is the kind of cycle that we would like to have, but unfortunately, this is what happens in many of the drylands, because pasturage is not really managed properly. Second factor that contributes to desertification is biomass burning. A lot of forest is removed for cultivation. When that happens, of course, the burning of the agricultural waste and fuel wood, that is very common in the tropics and subtropics. And in Africa, of course, this affects throughout the year, particularly in the dry season. And the emissions from the biomass burning, of course, contribute not only to desertification, but also to greenhouse gas accumulation in the atmosphere. And of course, that also contributes to climate change. So this is just to give you an idea of what happens due to emissions from the biomass burning: carbon dioxide, carbon monoxide, methane, and ammonia. And you see that carbon dioxide is the maximum amount of emission, and then of course 42% of the total biomass burning is due to carbon dioxide. And then of course you have carbon monoxide, methane, and ammonia. And what happens in different regions is that most of the biomass burning you notice here is from Africa. And you notice here that 42% is contributed by Africa, followed by South America. This is not surprising because Amazon is being cleared very rapidly in South America, and that is why the percentage emissions is more in South America, followed by Asia. In Asia, of course, the problem is most of the arable land is already cultivated. There is not much left anymore, and that is why you don't have much of biomass burning happening in Asia. But of course, due to human population increase, people do move into marginal lands, and then when they start clearing marginal lands, that could be a major problem. So not only the burning, what happens in agriculture is that you also contribute to air pollution. A lot of people think that agriculture we don't think of agriculture as a source that contributes to the state of climate in which we are today. But a lot of these impacts of agriculture could be on environment because of the air pollution and other factors that I just talked about. So the effects of biomass burning is that primarily it contributes to the atmospheric budget of trace gases. You have ozone that from the biomass burning that makes up 38% of all the tropospheric ozone. 50% of all nitrogen in the biomass is released as N2 during burning, and this causes sizable loss of fixed nitrogen in tropical ecosystems. And of course, they can modify the atmospheric chemistry. Climate change itself, however, may cause temperatures to rise in the dry season. And then of course when that happens you have increasing fire risk, and then you have greater pollution. When we clear forests, we accelerate soil erosion, and that's what is shown in the figure on the right side, that when you leave the soil bare because of clearing for agriculture, early rains cause a lot of erosion impact, and this could be by a factor of 50 or more. And then of course, when you have accelerated erosion, it affects the carbon dioxide pool in the soil. And of course, the fluxes of carbon between soil and atmosphere because of the breakdown of the soil aggregates. And more of the carbon is exposed to climatic elements, and you have mineralization, and of course you have disrupted aggregates and redistributed soil. And all of this, of course, the net result is that you are losing the soil organic carbon. So this is just a schematic that shows you what happens with desertification. deforestation, when you remove the forest cover, you actually have a lot of these impacts due to deforestation. And then when you actually do change the forest cover, the impact on, there are a number of different impacts. The first impact on the first 4 boxes is impact on the ecological functions and services. The middle ones in yellow are the physical impacts of change in functions, and the last one is socio-economic impacts. When we actually do the deforestation, there are 2 things that happen. We are actually disturbing the water cycle. On the left side, what you see here is that if you have a good forest, it maintains the natural water table, because the forests keep circulating water from deep down in the soil into the atmosphere, and hence you have a healthy agricultural crop downslope, and then soil salinity is maintained at the subsurface soil depths. On the right side, you see deforestation. When you have deforestation happening, you are actually affecting the water table. The soil, the saline water rises, and hence you have a lot of salinity that is moving up, and then a lot of that saline water runoff also causes an impact on the ecosystem's downslope. So on the right side, you have the negative impact of deforestation due to increased salinity, and then of course this is the reason why we need to have good forest cover and good maintenance of forest cover. And when you have irrigated agriculture that is not managed properly, managed irrigated agriculture, of course, is what contributes to a lot of agricultural productivity around the world. More than 60% of the total productivity in agriculture is because of irrigated agriculture in the world. If you don't manage agriculture properly, of course, irrigation properly, you can in fact bring in this additional issue of salinity. And that is what is shown here in the figure on the right. Out of the 230 million hectares of irrigated land today, 45 million hectares are salt-affected lands. That's really disturbing, because that's almost 20% of the total amount of irrigated agriculture. Out of the 1.5 billion hectares of dryland agriculture, 32 million are salt-affected, approximately 2%, to varying degrees because of the way we mismanage irrigation. The next factor I would like to talk about is the impact of drought and removal of vegetation on sand and dust transport. As a whole, in the arid and semi-arid regions of the world, 24% of the cultivated land and 41% of the pastured land is affected by moderate to severe land degradation due to wind erosion. And worldwide, there's a lot of this dust that rises in the air and then that moves literally several hundred kilometers. And this kind of deflation of soils and sediment is estimated anywhere between 60 to 360 million tons. In Africa alone, 100 million tons of dust per annum is blown westward over Atlantic. And many of the Mediterranean countries in southern Europe, of course, see this problem, the dust that is carried from Africa. And in China, the data show that from the 1950s to 1990s, the wind erosion problem has become very serious. In the 50s, it was happening about 5 times in a year. By the 1990s, it has increased to about 20 times in a year. So you could see that the sand encroachment, desert encroachment annually is burying about 210,000 hectares of land in China. And let me give you a couple of examples from Africa. What is happening due to desertification? 65% of the extensive cropland degradation is accounted for by Africa. 485 million Africans are affected by land degradation. And not only that, the annual cost is enormous, $9.3 billion every year due to land degradation. But unfortunately, despite these kind of numbers, the donor assistance in terms of helping to control land degradation is not up to expectations, and the problem continues to be serious. In the Mediterranean coast, land degradation in the northern parts of Africa, especially the coastal areas of Algeria, Egypt, Libya, Morocco, and Tunisia. The main types of soils in these regions are calcisols, gypsysols, ribosols, serinosols, and luvisols. This is could be a jargon for some of you who are not familiar with the soil types. What this really tells you is that most of these soils are light soils that can be very easily degraded. The severity of land degradation in the Mediterranean coast is variable, but you see that 33,000 square kilometers is categorized as very low, 23,000 as low, and 74,000 as medium. So you could see that the severity of land degradation in the Mediterranean is primarily in that medium category, 74,000 square kilometers. Just to give you some publicity about my own organization, how are we addressing drought and desertification? We are a specialized agency in the United Nations for weather, climate and water. The 187 member countries are members of WMO, who are the National Meteorological and Hydrological Services, and most of you are familiar with your local meteorological service that provides you forecasts every morning and also climate forecasts and so on. We have regional and national centers. We have a number of bodies with which we have partnership, and it would be of interest to me perhaps to also discuss as to how WMO could assist CIHAN following the presentation that I heard this morning. We also issue seasonal and monthly forecasts and transfer of knowledge and technology. We have a number of different scientific programs. Knowledge of the climate system is one of the most important. Along with UNEP, we established the IPCC, and Dr. Zuzel, of course, is a member of the Bureau of IPCC, and most of you know that IPCC shared the Nobel Peace Prize last year along with Senator Al Gore. We do systematic and standard observations, we do analysis, research and modeling, and also specialized observations. We emphasize drought and desertification, and we have been doing it ever since the establishment of WMO in 1950. There are three programs: my own program, Agriculture Meteorology Program, the Hydrology and Water Resource Program, and Technical Cooperation Program. All of us concentrate on these issues. WMO also facilitates research across the world in a number of different atmospheric processes, the biophysical feedback mechanism, the numerical climate models. This is what really contributed to IPCC assessments. The understanding of how global energy and water circulates, the interactions between desertification and climate. We also have a big program on satellites and how we could use satellites to monitor weather and climate. And then, of course, the whole issue of climate variability, we have a major program. We also work on early warning systems for drought. We have three major components. GOS is the Global Observing System, GDPS is the Global Data Processing System, and GTS is the Global Telecommunication System. The forecasts that you receive every morning, they don't just happen automatically. We distribute the observations made by 187 member countries on the global telecommunication system, and these data then go to all parts of the world, primarily the major forecasting centers, and then they massage the data, and then every morning you receive your forecast. So this is primarily because of the cooperative network that WMO has established over the years. We also provide climate outlooks, and we contribute to all phases of disaster preparedness. In terms of our own agrometeorological applications, we do drought monitoring, forecasting and control. We also look at various aspects of drought processes. We also emphasize how we can operationally use the knowledge of agrometeorology to manage droughts, primarily drought preparedness, and how to alleviate the effects of droughts after droughts have occurred. And with UNEP, we produced a book called Interactions of Desertification and Climate some years ago, and we also emphasize capacity building. We also have a hydrology and water resources program, and they run these what are called as World Hydrological Cycle Observing Systems, because by 2025, 2/3 of the world population would be living in countries with medium to high water stress. It's very important for us to monitor what is happening in terms of hydrological cycles so that we can manage the water resources properly. We have a number of these hydrological observing systems in different parts of the world. It's really a vehicle for us to disseminate high quality information and to promote international collaboration. Thank you very much.